All right, so we will also then look at the derivatives of exponential functions. All right, and so specifically the first one we will look at, the derivative with respect to x of a raised to a power x is equal to a raised to a power x times the natural log of a. The derivative with respect to x of e raised to the power x is e to the x. All right, so I want to back up here and just quickly address sort of a common careless error. Here it is. All right, so I want you guys to kind of just quickly help me put some examples of functions into their families of functions. All right, so the first one I have for you, f of x is equal to x squared. Can you tell me how to categorize this function? It is parabolic. How about that guy? Could you come up with one sort of family of functions that we could put all of those guys into? This is a power function, right? All right, so write them down again. F of x is equal to x squared. This is a power function. All right, and so when we take derivative of a power function, we use the power rule. All right, the power rule said when you take derivative of a power function, so for instance, a power function we said was a coefficient times x to the power n. So when we found a derivative, it was equal to n times c times x to the power n minus 1. Remember the power rule of derivation? We use the power rule when we have a power function. What type of a function is this? How do we categorize this guy? That's an exponential. Very good. This is an exponential function. Do you think that it is appropriate to use the power rule that is meant for power functions to find the derivative of an exponential function? It is not, right? So we don't use the power rule when we're dealing with exponential functions. Exponential functions will have their very own rule. And that rule, like we just saw, was this. So if you had f of x equals 2 to the power x, then the derivative f prime of x is 2 to the power x times natural log of 2. Okay? So don't confuse power functions with exponential functions. All right, so let's see if we can use these rules of finding derivatives of exponentials to give the derivative of y equals e raised to the power negative 5x times cosine of 3x. I'm going to need to use both the product rule and the chain rule for this example. So y prime is equal to, let's start by finding derivative just of the first. Let's separate these guys. So the first and the second. Derivative of e raised to the power negative 5x. So by the chain rule, derivative of the outside, derivative of e raised to some power is e raised to that power times derivative of the inside. The derivative of negative 5x is equal to negative 5. So all of this stuff here together, this constitutes derivative of the first times the second plus the first. The first is just e to the negative 5x times derivative of the second. All right, so help me out here. Derivative of cosine of 3x. This is going to, again, require the chain rule. Derivative of the outside, derivative of cosine is equal to negative sine. Leave the inside alone, so leave the 3x alone, times derivative of the inside, derivative of 3x equal to 3. All right, questions? That's good. All right, this example was like really advanced for a first example. Let me insert another example for you guys here. Please find for me the derivative of f of x is equal to e raised to the power x squared plus 1. What will the derivative be equal to? All right, so this is a composite function. The outside function is e raised to some power. The inside function is x squared plus 1, right? So derivative of the outside. What is the derivative of e to the x? It's just e to the x. Derivative of e to some power is just e to that power. So derivative of the outside is just e raised to the power x squared plus 1 times derivative of the inside. What is the derivative of x squared plus 1? 2x. Okay? How about, let me ask you this one first. All right, g of x is equal to 4 raised to the power x. The derivative, g prime of x, is equal to 4 to the power x times natural log of 4, right? Now let's complicate this just a little bit. What if I give you a function h of x is equal to 4 raised to the power sine of x? Is this still an exponential function? What do you think? By the way that we categorize these, is this still an exponential function? It is, because my variable x shows up in the exponent and in the exponent only. So yes, this qualifies as an exponential function. However, it is composite. What would you, the outside function here is what? 4 raised to some power, right? So the outside function is 4 raised to the power x, or 4 raised to some power. The inside function is sine of x. So when we take the derivative here, h prime of x, again, just take derivative of the outside. What is the derivative of 4 to the power x? 4 to the x times natural log of 4. All right, but now just instead of x, we have a function plugged in there. So the derivative of the outside would be 4 to the power, just leave the inside alone. So 4 to the power times natural log of 4 times, now we get to take derivative of the inside. What is the derivative of sine of x? It is cosine of x. Right. You guys okay so far? All right, let's look at more of these examples that are given here. Number 2, f of x is equal to 3x raised to the power 6 times e raised to the power 2x. So here again, we're going to have to use both the product rule and the quotient rule to find this derivative. All right, so f prime of x is equal to. So again, in my product, I'm going to just make sure I clearly indicate this is the first, this is the second. So the product rule says this will be derivative of the first, so that is the derivative of 3x to the power 6. That's equal to 18x to the power 5, derivative of the first, times the second, e to the 2x, plus the first, 3x to the power 6, times derivative of the second. All right, what is derivative of e to the 2x? By the chain rule, derivative of the outside would be e to the 2x times derivative of the inside, which is equal to 2.